This is Mathlet Review Part 5. Again, you can also use this to review for other examinations, not necessarily on the licensure examination for teachers. This is focusing on the solving problems involving the least common multiple. September is packing equal numbers of sliced bread in bananas for snacks. September stocks the sliced bread in groups of 18 and the bananas in groups of 9. What is the smallest number of grapes that she can pack? This is very exciting. There can also be three methods. The methods that we used with solving problems involving the greatest common factor can still be solved here, but we will just be focusing on one. You can also use it anyway. We have already done it in the previous video. So we will only be making use of one method here. So what we do, we'll be using the ladder method. So we write 18 and 9 side by side. So we start by asking ourselves, is 18 divisible by 2? Our answer is yes. But is 9 divisible by 2? No, 9 is not divisible by 2, so we move with 3. Is 18 divisible by 3? Yes. Is 9 divisible by 3? Yes. So our first factor will be 3. So 18 divided by 3 is 6, and 9 divided by 3 is 3. And we continue. Is 6 divisible by 2? Yes. But is 3 divisible by 2? No. But is 6 divisible by 3? Yes. And 3 is, of course, divisible by itself. So we can write 6 divided by 3 is 2, and 3 divided by 1 is 1. What we usually do is we make all numbers at the bottom part equal to 1. So if there are non-1 numbers here, a number that is not 1, then we just have to divide it by itself. So 2 divided by 2 is 1, and we just have to bring down 1 because that's already 1. So what we will be doing is we are only going to multiply the numbers at the sides here on this side. So 3 times 3 times 2 is equal to 18. So that's 18. So the smallest number of grapes that September can pack, having 18 slices of bread and 9 bananas. So that will be 18. So 18 will be the smallest number. So if we are going to do it also with the other method, that will still give us 18. All we need to do for prime factorization is we just multiply everything that is common, including the one that are not common. And of course, for the listing method, we also have to do it the same way, in a different manner. But we will have to use this one because this one is easier. Next, October is thinking of a number that is divisible by both 17 and 8. So we write 17 and 8. And that we are going to think of the smallest number. So is 17 divisible by 2? No, so we cannot use 17. Is 17 a prime number? Yes, it's a prime number. The factors of 17 is just 17 in itself. So we start with 17. 17 and 8. We bring down 8 because we cannot divide 8 by 17. So since that's already 1, we just have to think of the prime factors of 8. So that would be, we just have to bring down 1, and 8 divided by 2 is 4. And 4 can still be divided by 2. So that gives us, bring down 1, and 4 divided by 2 is 2. And we still have a 2 there, so we just have to multiply it by to divide it by 2. So we bring down 1, and 2 divided by 2 is 1. So all we need to do is we just have to multiply 17 by 2 by 2 by 2. So, oops, 2 here, and there's a 2 here. So this is 34, and this one is 68, and the last 2 times 68 is that 16 carry 1, 12, 13, 136. So that's 136. 136 is our smallest number that October could be thinking of. That is both divisible by 17 and 8. So we moved on to our next number. Our next problem, November wishes to advertise her new business, so she gives packs of 13 red flyers to each restaurant owner and sets of 20 blue flyers to each clothing store owner. At the end of the day, November realizes that she gave out the same number of red and blue flyers. What is the minimum number of flyers of each color she distributed? So what we will be doing is, again, we will be writing 13 and 20. The easiest way, this is another strategy that you can use if you are familiar with the basics of mathematics. If one of the numbers is already a prime number, so you say prime when the number has the factors of the number is only 1 and itself. So for example, 13, the factors of 13 is only 13 and 1. So the easiest way to do this will be multiplying 13 and 20, which will basically give us 260. 260. So it would mean that the minimum number of flyers of each color she distributed is 260. So let's try to apply just to be sure, if you are hesitant to believe that it's 260. So we apply the ladder method. So we start with 2. We just bring down 13 because we cannot divide it by 2, and that's 10. And then we have to do 2 again, and then we have 13, and then 5, and then 5 is already an odd number, so we have 5 here. Then we have 13, and then 1, and then we just have to take out 13 here, and then we have 1 and 1 below. So if you can see, if we will be multiplying 2 times 2 times 5 times 13. 2 times 2 times 5, that's basically 20. So if we multiply 2 by 2, by 5 by 13, that will still generate exactly the same answer, and that is 260. So our answer is the same, whether we use a different method or not. But we have to be careful that you can only do this if one of the number is prime. One of the numbers in the given is prime. So November will have 260 flyers so that she can distribute it evenly to the different restaurant owners. Next problem, December. So I'm using here the names, the month as names of people. So December sells hand towels in sets of 17 and bath towels in sets of 6. If the store sold the same number of each this morning, what is the smallest number of each type of towel that the store must have sold? So we will be having still the same process. You're right, 17 and 6. So we check first the number. Is 17 a prime number? Do we have other factors of 17 aside from 17 and 1? If there's none, if 17, if we have proven that 17 is really a prime number, so we just simply multiply 17 by 6. So that's 42 and 102. So the smallest number of each type of towel that the store must have sold is 102, so that it can sell to the same yeah, that's the smallest number that the store can sell in each day, yeah, each morning. Okay, so 102 hand towels and 102 bath towels. Okay, we moved now to our last problem. So January stationery sells cards in packs of 11 and envelopes in packs of 13. So we have 11 and 13. If February wants the same number of each, what is the minimum number of cards that she will have to buy? So we analyze first, is 11 a prime number? Does it have any other factors aside from 11 and 1? So we can conclude that 11 is a prime number. And that also goes with 13. 13 is also a prime number because the factors of 13 is only 13 and 1. So what we will be doing is we multiply it directly. So that's 3. We cross multiply 3. That is 4 and 143. So verify. 13 times 1 times 11, I mean. That's 3 and 3, and that's 1 and 1. So it gives us 143. So January will have to sell 143 uh, packs of envelope and stationery and cards, and 143 cards, so that she will be able to sell. That's a minimum number of cards that she will have um, to sell. Okay, so that will be the part 4 for our review for focusing on LCD. So don't forget to subscribe, like, and hit the notification bell to be updated with the upcoming videos. Thank you so much and have a good day.